Now here onwards your actual design starts. So design of stator. So actually the stator and rotor, these are the two main parts of any induction motor. So before proceeding to any design, so we have to design the stator first. So as we all know, specific magnetic loading BAV is equal to 5P upon pi dl. So if you convert, or if you want to calculate the value for phi m is equal to BAV pi dl upon P. So this is just the arrangement for phi m. Now as you all know, stator voltage per phase is given by 4.44 F phi m. This is stator winding turns per phase. And what is this? This is nothing but your stator winding factor kws, so which is having the value of 0.955. so it may vary between zero point 0.9 to 0.956. So depend on the application, we are taking the value of stator winding factor. So now from this equation you can able to calculate stator turns per phase. TS is equal to ES upon 4.44 into kws into F into pi. So stator turns per phase is the first step in calculating design of stator. Next one is stator conductor section. Now stator conductor section is nothing but your, so for calculating the stator conductor section you have to calculate the stator current per phase, and after that you have to assume some current density, and then only the cross section of each conductor is able to calculate. So how to calculate the stator current per phase? It is having the simple formula which is there in the kVA rating of the induction motor itself. So stator current IS equal to kVA into 1000 divided by 3 times ES ampere. Okay, so this is the simple relation, no need to elaborate it. Now cross section of each cross section area of each conductor, it is given by stator current divided by current density of stator conductor. So remember, current density of stator conductor, it is always selected in between 3 to 5 ampere per mm square. So as stator current is given in ampere and current density it is given in ampere per mm square, the only remaining unit is mm square, which is nothing but cross section area of each conductor, where delta S is current density. Now generally round conductors are preferred. Now here this AS is nothing but cross sectional area of each conductor. Here the practical conductors are shown. So as we know the cross section area, now round cross section conductors are selected if your current requirement is low, and rectangular conductors are selected if your current requirement is higher. Now these, the conductors shown here, they are round conductors. That means what? Here your current range is low, but for higher current range we are going for rectangular conductors. Now again stator slot design, you know, for induction squirrel cage induction motor we are having slotted stator as well as squirrel cage rotor, but in case of squirrel slip ring type of induction motor we are having slotted stator as well as rotor. So here in stator slot design, remember there are two types of slots. First one is open slot, second one is semi enclosed slot. So here this is the diagram for open slots, this is the diagram for semi enclosed slots. Now what is the difference, or when we are going for open slots and when we are going for semi enclosed slots? So when there is a, when you want reduce leakage reactance, we are preferring open slots, as well as when there is a small value of magnetizing current, for better power factor we are preferring semi enclosed slots. So remember this thing, To reduce leakage reactance, you must prefer open slots, and for small value of magnetizing current, that is IM, as well as for better power factor, you must go for semi-enclosed slots. But as you all know, there are some limitations of these semi-enclosed slots. The limitations include, they are the installation of winding is difficult in case of semi-enclosed slots, where installation of winding it is easy in case of open slots. So that's why this is the advantage here, ease of winding installation. Here we are not getting that ease of winding installation. After that, this open slot is used for large and medium size motors, and for small size motor we are using semi enclosed slots. So remember this thing, for large and medium size motor we are preferring open slots, and for small motors we are preferring semi enclosed slots. So the motor which you are using in your house for pumping the water from ground to the uppermost tank, in that half HP motor we may use semi enclosed slots, and for medium and large size motors we are using open slots.